All right, so we're Group 9, and for our project, we decided to test different algorithms for the purpose of image segmentation. My name is Jake Krajewski.
I'm Alicia Esquivel.
Dewi Karismawat.
Aaron Neidlinger.
Evan Teters.
Image segmentation is the most important task in image analysis and computer vision right now. And then in this project, we are trying to focus on comparing between crisp, fuzzy, and local information clustering on image. And in here, we want to try to compare them and investigate like how are they doing, how they performs, which algorithm works better in noisy images, and also we also want to experiment with parameters on each algorithm.
So for our data set, we decided to use this image of balloons since there's a lot of variance in colors, and then we could test it on different types of clusters. The first image you see is the regular image, and then the second one we used salt and pepper to add a little noise to it, so we could see how the algorithms deal with the noise.
Well, basically, we were comparing as well k-means and mean-shift clustering. We conclude with the next statements. The first one is that k-means and mean-shift segmentation are two Crip clustering algorithms. They will have problems when clustering ambiguous color images. If the input of number of clusters k is small, then some clusters colors are missing in the segmentation result. If the input of number of clusters k is big, then the segmentation result will be better. As well, we concluded that as bandwidth values increases, the number of clusters colors decreases, and as bandwidth values decreases, the number of clusters colors increases.
So fuzzy C-means was the first clustering algorithm to be introduced to use fuzzy information. It allowed for membership values to say how much a data point belonged to a certain cluster. It, however, wasn't extremely suited for image segmenting tasks, and we kind of found that the image segments that it made were not really very good segments, and it did not hold up to noise very well. So after fuzzy C-means, at one point was introduced fuzzy local information C-means, which was an improvement upon FCM that used local information, so kind of a sliding window that looks at pixels near every pixel to determine how likely it is that clusters will be created, which significantly helped membership values. And we found, as you can see, that the clustering was fairly good. However, it still was not great at handling noise because of the way that membership values must always add up to 1, so noise gets an unfair amount of representation, and this was handled by possibilistic C-means.
So now we're going to talk about possibilistic local information C-means. The way this differs from FLICM is that the membership values don't have to sum up to 1 like they do in FLICM, and this leads to dealing with noise a lot better because the membership values of the noise is going to be a lot lower, and hence they get mainly removed and the image gets released moved out. For introducing noise to our balloon images, we wanted to see how the window size would actually offend, how it fends against the noise. And it turns out as the window size increased, we saw that the noise got deleted way more. And by the time we got to window size 7, noise seemed to almost completely be removed.
So one interesting challenge with using fuzzy segmentation is that the visualization that's left over is basically a crisp visualization where only the classifiers that they belong to are going to show up. So you see just straight colors there. So we designed something called a fuzzy segmentation visualization that converts the image and uses membership values to tint each pixel. So you can see that on the right. The smaller the membership value is for a pixel's cluster, the less confident the decision is for it to belong to that cluster. So it becomes lighter. So you can see around the edges of most clusters there's a much brighter white color because that's where the algorithm is the least confidence in its placing.
All right, that's all for our project. Thanks for watching and listening.